Thank you for joining our demonstration of Lozen for revolutionary data access. My name is Jeannie Glass, and I'm CEO at VirtualZ Computing. And with me is Richard Philyaw, our Chief Architect. There are thousands of packaged applications like Tableau and others that require access to data residing on IBM Z, where over 80% of the world's business critical data is stored. Today, customers spend millions of dollars creating and maintaining custom code and expending their high-value mainframe capacity on legacy data access methods such as ETL, FTP, and change data capture. With these methods, customers are limited to extracting and transferring terabytes of read-only, out-of-sync copies of their mission-critical data across their network. In addition to packaged applications on the right, this data access problem is compounding as the number of application migration projects increase, creating more demand for more access to more business data residing on IBM Z. Oftentimes, after several years and millions of dollars have been spent, customers still don't have an early migration success they can point to, leading to high abandon rates. This is where Lozen comes in. In addition to real-time read-write data accessed by packaged applications, Lozen delivers unprecedented benefits to application migration projects by allowing customers to migrate just their applications and leave their data securely where it is. Lozen drastically reduces the risk, time, and expense of your application modernization projects. With Lozen, your data stays where it is on the IBM Z platform, eliminating the need for ETL, custom code, change data capture, and other legacy methods. You maintain real-time read-write access by your applications that have been migrated to the cloud and distributed platforms, and the data dependencies for those applications remaining on IBM Z stay intact as well. But that's not all. Lozen delivers additional cost savings by reducing your MIPS consumption through our zip engine architecture. And now I'll turn it over to Richard, who will share a short product demonstration.
Welcome to our short demo of Lozen from VirtualZ Computing. Our demo environment consists of an IBM Z mainframe running ZOS connected via a TCP/IP network. In the first example, we will demonstrate accessing a vSAM key sequence dataset, or KSDS, from a commodity Linux x86 server. In our second example, we will show a similar scenario with a Windows system running the Lozen Microfocus Cobol integration. Notice the various file types that are supported by Lozen. They include all forms of vSAM, KSDS, RRDS or relative record datasets, and ESDS or entry sequence datasets. In addition, Lozen currently supports ordinary sequential files such as QSAM and BSAM, as well as partition dataset files, PDS and PDSE. We can also provide access to the ZOS Unix Services file system, and in fact all files in either HFS or ZFS file systems. Before we begin the demo, let's take a moment to review some important elements of the Lozen ZOS server installation. Here we see a simple Unix-style shell created by accessing our ZOS system via SSH or secure shell. If we list the contents of the VirtualZ installation directory, we can see the structure of the Lozen installation, including important folders such as bin, which contains the Lozen ZOS executable, clients, which contains optional components that can be installed on distributed platforms, conf, which contains the Lozen configuration, and others pertaining to the operation of Lozen. Another important folder is data. Let's take a look at this so we can understand the power, simplicity, and convenience of using Lozen. In the data folder, we see a list of special file system entries that are specific to IBM ZOS, external links. These are aliases that provide simple and convenient access to, for example, VSAM files that will seem more familiar on the distributed systems. In our Linux example, we will refer to our VSAM data using a simpler lowercase name rather than the mainframe style name in uppercase using high-level qualifiers. It's the same file, just using a friendlier name to the Windows and Linux user. Let's quickly take a look at one of our test data files using the ZOS ISPF file manager. Here you can see we are looking at the vents.test KSDS file. We see 10 simple 80-byte test records with the key starting in position 0 and the data starting in position 9 for each record. If we view the catalog information, we see that it is KSDS with no alternate index. Lozen does support access to an alternate index if it is present. Now, let's move on to accessing this same data from a Linux shell so we can see how we've simplified all this complexity. The first thing we'll need to do is connect to our ZOS system. The connection is made using a familiar Linux command, mount. On the mount command, we specify that we want to use the NFS protocol. We also specify the name of our ZOS server and the location in the ZOS file system we want to access. Finally, we give a name to the mount point that we will refer to in our Linux shell. This is not a special name. It can be any string that is a valid Linux directory name. We execute the mount command, and that's it. We're now connected to our ZOS server. You'll notice we didn't specify any security credentials. This is an important aspect of both the power and simplicity of Lozen. The Lozen server maps the Linux user ID to a ZOS security context that is configured with standard ZOS tools such as RACF or Top Secret. By simple configuration, the complexity of ZOS security requirements is hidden from the Linux user. All the robust security we are accustomed to on ZOS is in place and will be automatically enforced. Once the connection is made, it can be verified by any Linux file system command. Here we see the df command being used to view the total and available space in the file system we just mounted. Note that the format of the information is exactly what you would expect from a Linux file system. Lozen has automatically mediated and interpreted the ZOS file system metadata in a meaningful and familiar way. Now we can view the data in the VSAM file, again with a command line that is totally familiar to a Linux user. We use the cat command against a file name alias we defined with the external link command on ZOS that points to the same file we viewed using the ISPF file manager on ZOS as vents.test KSDS. The cat command output is piped through the iconv command to convert from the EBCDIC IBM 1047 code page to the UTF-8 used on the Linux system. We then pipe that output through the stream editor sed to convert the byte stream format output by cat into the same 80-byte record format we saw on ZOS earlier. If we reissue the same cat command line, we again see the same data, but something very important has just happened. Lozen and NFS cooperate to provide robust data caching at the client, with a quick call to the Lozen server to determine whether any of the data has changed since the last fetch. In this case, the records are retrieved directly from the local cache without incurring any additional network or ZOS file system I/O. Let's mention one final thing before we move on to our next demonstration. There is no Lozen software installed on our Linux system in this case. By simply issuing an NFS mount, we have connected to and interacted with the Lozen server on ZOS. NFS clients are a standard part of most Linux and Windows distributions. The Lozen server is compatible with NFS clients all the way back to NFS 3.1. If NFS 4.1 or 4.2 clients are present, Lozen will still work, but will work faster and more efficiently, taking advantage of the advances in the NFS protocol that appeared in version 4.1. Let's now move on to the final part of our demo. Lozen ships with optional components that can be installed on distributed systems. One of these is our microfocus integration. We have implemented the microfocus Cobol external file handler interface and embedded Lozen and NFS functionality that allows a Cobol program written for indexed file handling to execute on a Linux or Windows system, but accessing VSAM files resident on IBM Z. This means you can take your existing IBM Z Cobol programs, recompile them using Microfocus Cobol, and execute them without any code changes on Linux or Windows and without moving any data off the mainframe. Let's switch to our Windows system now and show the installation of that Lozen file handler. As you can see, it is a familiar Windows installer program. We enter the IBM Z hostname, the server port to connect to, and the ZOS file system mount point. That's all there is to it. The components are installed and can be found in the expected programs directory in Windows. Post-installation, you simply edit the file handler config file to specify file name masks that will be automatically handled by Lozen. Now let's take a look at the Lozen file handler in action in a Cobol program. Here we see an unmodified Microfocus sample program. The Cobol code declares an indexed file that it will access by key. The file contains information about airports. The program will retrieve 2 airport records and calculate and display the distance between them. Let's now build and execute the program. Here we see a dialog that prompts for the 2 airport codes displaying the calculated distance. Using the power and simplicity of Lozen, the program, without modification, has retrieved the 2 airport records from a mainframe VSAM file. We can directly access the single source of truth held in the mainframe VSAM file to obtain just the data we need without making any copies or extracts of the VSAM data. Thank you for your time and attention. We hope you found this useful. Please contact us at VirtualZComputing.com for any questions or to request a more in-depth discussion or for more complete technical and architectural details. We will be happy to arrange a trial of Lozen to help you on your mainframe data journey.